Alright, so tonight we are going to be talking about constant rate of change and slope. Now, actually, some of this I'm going to show you here, and some of this we're actually going to talk about in class tomorrow. We're not going to talk about it. I'm just going to tell you a good story in class tomorrow. So you just have to ask me about my slope story, and we'll see how well that comes across. We'll see how many of you watch the video and ask. What you have to know is that a rate of change is a rate that describes how one quantity changes in relation to another quantity. In a linear relationship that we've been looking at, the rate of change is actually constant. If you think about slope, if you think about the slope of a mountain, the slope is never change. It always is the same. It's constantly the same going down. And we could talk about different runs on a ski. That there's some are steeper than others, and that's true. And slopes do have that. But within a particular run, you are going to have the same type of slope. This is called a constant rate of change. The following table shows distance traveled on a zip line. I want to see the constant rate of change between the quantities. So for example, I have time, which is in seconds, and I have distance in feet. So if I go 2 seconds, I've gone 12 feet. If I go 4 seconds, I've gone 24 feet. 6 seconds will give me 36. 8 will give me 48, and so on and so on. To find the constant rate of change, what I'm really going to look at is how things change. So for example, I'm going to look at the change in the distance over the change in time. And why do I put distance over time instead of time over distance? It's basically I'm putting the dependent variable over the independent variable. And since the distance I travel depends on how long I've traveled for, distance will go on top. I notice that the distance changes every time I look at this. It's changing by 12 feet. And the time, every time it changed by 2 seconds. So what I end up getting then is that my constant rate of change ends up being 6 feet per second. Now, when I look at my rate of change, I can do it through a table. I could also do it on a graph where I could look at how 2 points change, the changes between 2 points, and again looking at the change in the y over the change in the x, because the y is that. But let's look at it just a general talk about rate of change. And let's talk about, there are 3 types of change, rate of change. There's a positive rate of change, there's a negative rate of change, and there's a 0 rate of change. In real life, positive rate of change means we have an increase, a negative would mean a decrease, and a 0 will show no change whatsoever. If I was to graph it, a positive rate of change is that. A negative rate of change looks like that. And no rate of change is going to be a horizontal line. Now, when it's a vertical line, there's a whole nother issue that comes across, and we will talk about those later on. Slope. When we're talking about graphing and we're looking at lines on a graph, one of the things we want to find out is the type of slope it has. Now, when we're finding slope, the most important thing is that we are given 2 points. And we'll call them x1, y1 and x2, y2. And so those are my 2 ordered pairs, my 2 points on the line that I want to find the slope between. Now, to find the slope, we're actually going to start by using an abbreviation for slope. And no, we're not going to use S, because S has another meaning, but instead, we're going to let M stand for slope. There's rumors to why we use M. Ask me that again. Also ask me that tomorrow. But to find the slope, as I said, we want to find the change in the dependent variable over the change in the independent variable. So really what we're doing is going y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's take a look at an example of how this works. Let's say I have the ordered pairs 4, 3 and 8, 6. And I want to find out how I find the slope. So what I do is very simply, I mark one of these as x1, y1, and the other one is x2, y2. So then the slope is nothing more than y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which gives me 3 over 4. So the slope of the line that contains those 2 points is 3 over 4. Let's take a look at another one. How about if I asked you, and I want you to try this, to find the slope of 1, negative 5 and 8, 3. Pause the recording and try this, and then we'll look and see how you did. Okay, so let's see how you did. If you did this correctly, and it really doesn't matter which point you call x1, y1 and x2, y2, I just kind of do it in the order I'm giving them here. So the slope is going to be 3 minus negative 5 over 8 minus 1. Well, 3 minus negative 5 is 8, and 8 minus 1 is, of course, 7. So the slope is 8/7. Now, here's the most important thing. And this is why we've always told you this year, leave it improper, leave it improper, leave it improper. Because slope must be left improper. Slope, another way to think of slope is that slope is the rise over the run. It's the amount it goes up or down over the amount it goes to the right or left in some cases. It's not a mixed number. It's not some number in rise over run. It's just rise over run, which means it has to be left as a fraction in simplest form, but no mixed number. So it's proper or improper, but that's it. So that's why I want to get used to just leaving it. Don't convert them. All right, with that being said, I'm going to give you 3 to try, and I want you to come in tomorrow with these done and let me know what you get. So the first one are the points 4, 3 and 1, 2. And then I want you to do negative 1, 7 and 5, 7. And lastly, I want you to do 1, 3 and 1, 0. All right. Thank you very much, and we'll see you next time I see you in class.